For today's assignment, you're asked to solve systems linear equations by using elimination method. I'm going to do a few of the problems from the assignment in case you've forgotten how to do this or you just want to check your work. I'll be looking at number 1, number 3, and number 4 in this video. So elimination method, the name makes a lot of sense. You're trying to eliminate one of your variables. I need to get rid of my x's or I need to get rid of my y's. And the way you eliminate your variables is what you're going to be doing is adding your equations together. Remember, a system has at least 2 equations. So you're just going to be adding these equations together and hoping that one of your variables eliminate. So what you need for them to eliminate is you need the coefficients to be opposites. If one of them is positive, you better have the same number, but it needs to be negative. So the first problem is a great example of this. If I was to add these equations together, what you're going to notice right away is that the y's will cancel. They're going to eliminate. This is negative 12y and this is positive 12y. Well, when you add opposites, you always get 0, which is what we want. When I add the x's, a 4x plus a negative 3x gives me a positive 1x. And then when I add the numbers, a negative 8 plus a 12 gives me a positive 4. So by eliminating the y's, I found the answer to the x. We now know that for the point of intersection, our x coordinate is 4. Now it's just our job to find the y coordinate. And we're going to do the same thing we do with substitution. You're just going to pick one of your equations and plug this in. So you can pick the first equation or the second equation. I'm going to go ahead and pick the first equation. But now instead of x, I can now plug in 4. And now we just do some simple math. 4 times 4 gives me 16. Remember, our goal is to solve for the y, so I need to get rid of this 16. Since this is a positive 16, I'm going to subtract that on both sides. And a negative 8 take away 16 gives me a negative 24. And now I need to get rid of the negative 12. Well, since this is multiplication, we're going to do the opposite, which is to divide. And a negative 24 divided by a negative 12 gives me a positive 2. So we now know the y coordinate for our point of intersection is 2. So in the end, what we can say is that the line 4x minus 12y equals negative 8 and the line negative 3x plus 12y equals 12 intersect at the point 4, 2. 4, 2 is the solution to our system. Now let's look at a more challenging problem. Let's look at number 3. You're going to notice that if I was to try to add how these equations are right now, nothing would eliminate. The x's are not opposites and the y's are not opposites. So we're going to go to the plan B, which is to make them opposites. So you can choose to eliminate the x's or the y's. It's up to you. But I noticed that this is a positive 3. It's going to be really easy for me to make this a negative 3. Since this is already a negative 1, all I need to do is multiply it by 3. If I multiply a negative 1 times a 3, I'm going to get a negative 3. And that's going to be the opposite that I need. So what I'm going to do is I'm going to multiply everything on the bottom by 3 in order to create a new system that will eliminate. So I'm now going to have an equivalent system. The top one does not change. The 6x plus 3y equals 3. I just bring it down. But the bottom equation, I'm going to multiply everything by 3. 3x times 3 gives me 9x. A negative y times 3 gives me negative 3y. And 4 times 3 gives me 12. I'm now going to add my equations together. 6x plus 9x gives me 15x. The y's canceled. And 3 plus 12 gives me 15. I need to solve for x, so I'm going to divide both sides by 15. And x equals 1. So I now know that my x coordinate for my point of intersection is 1. To find the y coordinate, you do the same exact thing we did in the previous problem. You pick one of your equations, but this time you have 3 choices. You have the first equation, the second equation, and now you have that third equation recreated. Doesn't matter which one you pick. I'm going to go ahead and pick the second equation. But now instead of x, I'm going to plug in the 1. And this should be easy. 3 times 1 is simply 3. I'm solving for the y, so I get rid of the 3 by subtracting it on both sides. 4 take away 3 gives me 1. And remember, this is a negative 1y. I don't want negative y. I want positive y, so I need to get rid of that negative sign. The opposite of multiplying by negative 1 is to divide by negative 1. And 1 divided by negative 1 is a negative 1. So y equals negative 1. So we now know that the intersection of our lines, or the solution to our system, is 1, negative 1. And finally, let's look at number 4. Same thing, if I was to add these equations how they are, the x's will not cancel, the y's will not cancel, so we need to rewrite this so that they will cancel. And once again, you have the choice. You can pick the x or the y. I notice that this is a -6 and this is a -3. So what I'm going to do is I'm going to make this one a +6. So I'm going to make sure I eliminate my x's for this problem. It's not the only way to do this, but it's the way I see. Because I know that 3 times 2 gives me 6. So to make the -3 into a +6, all I need to do is multiply by -2. So I'm going to create a new system. The bottom one's not going to change. But the top one, everything gets multiplied by -2. So -3x times -2 gives me +6x. A 2y times a -2 gives me a -4y. And a -17 times a -2 gives me a +34. I'm now going to add my systems or my equations together. The x's will cancel to 0, but the -4y plus the 3y will be a -1y. And the 34 plus the -30 will be a +4. Remember, our goal is to find y, not negative y, so I need to divide both sides by a -1. So y is equal to -4. So we now have the y coordinate. It's our job to find the x coordinate. We just do the same thing we did in the previous problems. We pick one of our equations and we plug in. I'm going to go ahead and pick the first equation. But now instead of y, I can plug in the -4. So I'm going to have -3x plus 2 times -4 equals -17. Well, 2 times -4 is -8. Our goal is to solve for x, so I need to get rid of this -8. We're doing don't call max for midnight. The opposite of -8 is to add 8 to both sides. -17 plus 8 is -9, and now I need to divide both sides by -3, and we get x is equal to +3. So we now know that the intersection of our lines, or the solution to our system, for number 4 is 3, -4.